Hello, we are working on Module 4, Discrete Random Variables. A discrete random variable is a variable that takes on different numerical measures which are determined by the outcome of a random experiment. The thing with random variables is that we are trying to predict future outcomes. These are always theoretical in that we'll never know what the actual outcomes will be in the future, but they are discrete, and that means that the variable itself is countable or has a non-infinite amount of numbers. There's an example here. It says Jeremiah has basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends only one practice, and 2% of the time he does not attend either practice. We are asked to find x, which is the random variable, and then determine the values that x can take on. So the variable x is the number of basketball practices Jeremiah attends in 1 week. And the values of x, this is going to be the confusing part. Jeremiah can attend 2 practices in a week. He could attend 1 practice in a week, or he could attend 0 practices in a week. So 0, 1, and 2, or 2, 1, and 0. Now, most of our discrete random variables will be in a probability distribution. Recall that a distribution is just a fancy word for a table. So we're going to fill in the probability distribution to the right for this experiment. So the x values, again, are 0, 1, or 2, and they represent the number of times that Jeremiah attends a practice in a week. And also, if we go back to the word problem, it tells us that 90% of the time, Jeremiah attends both practices. So 90%, or really 0.9. Then it says 8% of the time, he attends only one practice. So for 1 practice, he attends 8%. So as a decimal, that would be 0.08. And if we continue reading, 2% of the time, he does not attend either practice. So 2% of the time, or 0.02, he attends 0 practices. Now, one thing about this discrete random variable and these probability distributions is that the probabilities must all add up to 1. So if we do 0.02 plus 0.08 plus 0.09, we would get, 0.9, we will get 1.0. So we always have to confirm that our probability distribution adds up to 1. All right, so the next thing we need to talk about is what is the mean? The mean is standard deviation of a discrete random variable. When we talk about the mean, since we're talking about predicting future outcomes of experiments, we're not necessarily talking about the average, as in we add them all up and divide. We're talking about what would we expect the outcomes to be. So we're going to use the word expected value, or rather the phrase expected value, whenever we're referring to the long-term average or the mean of a discrete probability. This is a theoretical probability, as probabilities can't be applied to a single outcome. We will ask the question, what would we expect the outcomes to be if we repeated the experiment many times? This means that over the long term of doing an experiment, over and over and over and over and over and over and over, you would expect to get this average. So, important concept, important phrase here. The mean is called the expected value. So that's what we want to make sure that we have in the back of our minds. Whenever we hear or see the words expected value, we always want to think of the mean. There's a formula here. The formula says the mu, again, mu is the population mean, or the symbol for population mean, is the sum. This sigma symbol here represents the sum of the x values times their probabilities, or the sum of x times p of x. Example 4.5 says find the expected value of the number of times a newborn baby's crying wakes its mother after midnight. Let the discrete variable represent the probability that a newborn baby's crying wakes its mother after midnight in a given week. So they're telling us the X, the variable, represents the number of times the mother is woken after midnight in a given week. Since there are 7 days a week, we have the variables 0 through 7, because a baby could sleep through the night. So to find the expected value, or the mean, for this probability distribution, we can make a new column, and we'll call this new column x times p of x, because we need to find the products and then add them all together. So let's zoom in on this. To find x times p of x, we will do 0 times 2 over 50, which is just 0. 1 times 10 over 50, which is just 10 over 50. 2 times 21 over 50, which equals 42 over 50. 3 times 9 over 50, which is 27 over 50. 4 times 3 over 50, which is 12 over 50. 5 times 2 over 50, which is 10 over 50. And when we multiply these fractions, we're really just multiplying the numerator times the denominator, or as I like to say, the top times the top over the bottom times the bottom. And then lastly, we'll get 7 over 50. Now, since all of these fractions have a common denominator, all we need to do is add up the numerators. So we have 0 plus 10 plus 42 plus 27 plus 12 plus 10 plus 12 plus 7. So let's see here, that would be 52, 62. No, that's not going to be very easy to add in my head. Let's just write this out. 10, 42 is 52 plus 27 is 979 plus 12 is a 1, carry the 1, 91 plus 10 is 101 plus 12 is 113 plus 7 is 120 over 50. Well, 120 over 50, mu is 120 over 50, is the same thing as 2 and 20 over 50, or 2 and 2/5, which would really just be easier to say 2.4. So the expected value is the number of expected times per week a newborn baby's crying wakes its mother after midnight, and that would be 2.4.